Yeah, see this problem. Two coherent monochromatic light beams of intensities I and 4I are superimposed. The difference between maximum and minimum possible intensity in the resulting beam is. Hmm. So the difference between the maximum and minimum possible intensity they are asking. Now what is the resultant intensity formula? The resultant intensity formula. What is the formula for resultant intensity? Yes, there is resultant intensity, which will be equal to what you mean here. This is I1 plus I2 plus what terminal 2 root of I1 I2 into cos theta. So here they are asking here the two coherent sources of intensity is given. The difference between maximum and minimum intensity. So you tell me now how much the maximum intensity? We have seen this as what? Tell me now. Root of I1 plus root I2 plus I2 whole square. It's a maximum intensity. And what about the minimum intensity? Tell me now. Yes, root I1 minus root I2 whole square. Substitute the values now here. I1 given I2 given 4I now. Simplify. I1 value given I1 is I given, I2 value given as how much now? 4I. Now simplify it. So, which is equal to square root of I1 is I plus that is square root of 4I whole square. So, how much this value will come here? This is root I plus that is 2 into root I whole square. So, means what tell me now? 3 root I now? 3 root I this whole square. The square of this value that is 9I. And this one, so this is I minus what will be now root of 4I is equal to that is root I minus 2 root I whole square which is equal to I root I na root I whole square that means which is equal to I. Now they are asking to find what tell me now the difference between maximum to minimum. Now they are asking to find this I max minus I min. So how much is value now? This is 8I. Okay. Next one. Light emerges out of a convex lens when a source of light is kept at its focus. The shape of wavefront of the light is where the source is located. Source is at focus. If the object is at the focus, where the image will be formed
at infinity.
at infinity, infinite distance. So if the light rays are infinite distance, then what type of wavefront it can able to form? The cylindrical. हाँ, so see this thing here. We have seen different type of wavefronts के बारे में हमने discuss किया yesterday. So what are the different type of wavefronts here? If it is for a long distance, if the distance is very high, what type of wavefront it can able to form? Plane wavefront. So then here, when object is at focus, the image will be formed at infinite distance. So here we have this is object is there. Object is lies at the focus. Then the light rays and which will pass through the convex lens. After that, they will move to infinite distance. They will move like this. Keep on, they will move. Yes, what type of wavefronts now it will form? The wavefront formed by this is infinite distance. So these are called as a plane wavefronts now. These are the wavefronts are like this. What we'll call them? These are called as a plane wavefronts. Okay, the wavefronts are like this. So these are called as a plane wavefronts. Next one. Now see what they're saying here. Given below are the two statements. Okay. The phase difference between two light waves change if they travel through different media having same thickness but different indices of refraction. The phase difference of two light waves change. Okay. If they travel through different media, yes, changes. Different refractive index is different means changes. Yes, the wavelength of the waves are different in different media. Okay. In the light of the above, yes, correct. Both both are correct. So the phase difference will changes. Yes, the relation between the phase difference and path difference, the relation which is given as phase difference that is given as delta phi by 2 pi and which is equal to path difference is delta x by lambda and time difference is delta t by capital T time period. This is a relation between the phase difference, path difference and time difference. Okay. Now here, so if the medium changes means refractive index changes means, then obviously phase difference will changes. Okay. So the C is correct option. Both are correct and R is the correct explanation. Next, two beams of lights having intensity I4I interfere to produce a fringe pattern on a screen. The phase difference between the two beams are pi by 2 and pi by 3 at A and B. The difference between the resultant intensities. Now, so look at now here they given it as what tell me now I1. I1 is given as I. Next I2 given as what you tell me now? I2 given as 4I. Now, what they're saying here? So here the phase difference between they calculate intensity at the 2 point they calculated. So you tell me now here where now at point A. at point A, the phase difference they given us how much now here? This theta, which is given us how much now? Pi by 2. And what is the intensity formula? What is the intensity formula basically? Resultant intensity formula. Right. So tell me now here. So resultant intensity, that is which is given as IR, which is equal to, this is I1 plus I2 plus what, tell me now, 2 root of I1 I2 into cos theta. Now you tell me now at the point A, they given that phase difference theta value given as a 90 degrees. Now we will find the intensity at the point A. Find the intensity at point A. How much will come? Put the values now here. Now the intensity at the point A, which will be equal to I1 is I2 is 4I plus what is not 2 into square root of I into 4I into cos 90. Cos 90 value how much? How much the cos 90? So the resultant intensity, which will be cos 90, 0 na? So we'll come it as 5y. Now tell me now this is at point A. Now let's find the at point B. At the point B, angle given as how much? At the point B, how much the phase difference is given now? So which is given as pi by 3, 60 degrees. Now you tell me now substitute this value in the equation. I1 is I2 is how much now? 4I plus 2 root of what, tell me now, 4I square into cos 60. Cos 60 value 1 by 2. So this 2 cancel. So that is how much will come here? This is 5I plus this is 2I now. Will come to be IR, will come to be 7I. And this is the intensity at the point B. This is the intensity at the point B. Right. Now they are asking to find the difference between these two. So that means IB minus IA. How much the difference you tell me now, which is equal to 2I. Okay. Next one. Two light beams of intensity given 4I, 9I interfere on a screen. The phase difference between these beams on a screen at point A is 0, at point B is pi. The difference of resultant intensity they are asking to find. Here also same relations. Tell me now what we can do. So here, yes, I1 is given as 4I and I2. I2. Now tell me now here. So at point A, what is the resultant intensity now here? Resultant intensity formula, that is I1 plus I2 plus 2 root of I1, I2 into cos theta. Now you tell me now at point A, what they given at the point A, how much the intensity they given? Hmm. How much the angle given? 0. So that means angle 0 means what type of interference is a constructive or destructive? Constructive interference means what we have a maxima will be formed or minima will be formed. So that means we have a constructive interference. So at the point A, we have a maximum now. How much the maximum intensity formula? That is root I1 root I2 ka whole square. So that means at point A, the intensity is what you tell me now here. That is root of 4I plus what tell me now root of 9I ka whole square. Okay. So how much the intensity you tell me now? So this value which will come to be 2 into root I plus 3 into root I. So this totality is 5 na. So this is IA which will come to be a 5 root I. So 5 root I whole square. 5 means 25 na. 25 into I. This is intensity at point A. Now at the point B, what they're saying here, how much the phase difference at the point pi means what will mean 180 degrees means what? What type of interference? No, what we'll call this is a at point B. At the point B, phase difference phi value given, angle given as 180 degrees na. So that means what type of interference is a destructive interference? Destructive interference means then intensity is how much you tell me now? Intensity minimum. So that means how much the intensity now minimum impedance formula? Yes, root of I1 minus root I2 whole square. Yeah, simplify and get it. Root I1. I1 value, this is root 4I minus root 9I whole square. How much this value now here? I mean is a root means 2 root I minus 3 root I whole square. So minimum how much this value root I? Root I whole square will come to be I only na? Yeah, so what we need to get? Yes, so this means IA minus IB. The difference between these two now, this is nothing but IB only now. So that is how much now? 24 into I. Next. Now, two coherent sources of light interfere. The intensity ratio of the two sources is 1:4. For this interference pattern, if the value of Imax plus Imin by Imax minus Imin is given as like this, then they are asking to find alpha by beta. So what is this Imax? Root of I1 plus root I2 whole square. I mean, hmm. Now we need what, tell me now? So we need this thing Imax plus I mean by Imax minus I mean. Yeah, tell me how much now. So then when you add these two here, what we'll get now here, if we expand now here, I1 plus I2 plus 2AB will form now. It is in the form of A plus B whole square plus A minus B whole square. So we'll come it as, yes, 2AB will come now. So this will come to be a 2 into what we can tell me now here, 2 into A plus B. So this 2 into A square plus B square, like this will come now. Next. And this is Imax minus Imin. That means what happens now when you subtract now here, so it will come 4AB will come, isn't it? 4AB. So this means 4 into A means what, tell me now? Root I1 into root I2 will come now. So how much will come? This is nothing but what, tell me now? I1 plus I2 by what, tell me now? 2 into square root of I1 I2. They given this as a I1 I2. The ratio of this intensity is given I1 by I2. They given as how much now? 1 by 4 they given now. So then we can put this thing here. Then Imax plus Imin. This value. Now, so we have this as a Imax plus Imin by Imax minus Imin, and which will be equal to what you tell me now here. So I1 is 1, I2 is 4 now. This is 1 plus 4 by 2 into 1 into 4 means 4 only. So this is 5 by 4 will come. Now they are saying it as what, tell me now here, this value they equated to 2 alpha plus 1 by beta plus 3 equated. So this is what, tell me now, 5 by 4. They are asking to find alpha by beta. Now cross multiply this thing here. 8 alpha plus 4 equal to what you tell me now, 5 beta plus 5 into 3, 15. How much will come here? Alpha by beta we need. Hmm? Yes, what we'll do then? Cross multiply and simplify it. Mhm. So if we simplify it now, what will can happen now? This value alpha by beta can be this result. How much will come here? You see this thing? This is 8 alpha, which will be equal to 5 beta plus 11. Now we need alpha by beta. Okay, but no, we are not able to get this thing here. Alpha by beta. So you can check the options now here, which can able to satisfy. Yes, tell me any some value so that it can satisfy this equation. Mm. Now, if we have taken this, that only we can do here. Alpha, if we have taken 2 and beta we have taken as 1. Check it now. Will this equation satisfy? Yes, so will satisfy things. So this is left side 16 side. So that means now they are asking the alpha by beta. That should be equal to what element 2 by 1. Here the verification only helpful. Next one. Similar type of problem. Now do this thing. The interference pattern is obtained with the two coherent light sources of intensity given 4 is to 1 and the ratio Imax plus Imin by Imax minus Imin. Just now we have seen this relation, that is Imax plus Imin by Imax minus Imin, and which is equal to what? Tell me now. Just now we have seen 2 into I1 plus I2 by what? Tell me now here. This is 4 root I1 I2 will come. Yeah, so this is nothing but what? Tell me now. I1 plus I2 by 2 into I1 I2. Yes, so they given I1 I2 given as a 4 is to 1 given na. So we can take it as a I1 as a 4, I2 as a 1, that is 2 into root 4. So it will come to be what? Tell me now. 5 by 4. Okay. X value is 4. Next one. Two light beams having intensity I and 9I interfere to produce a fringe pattern on a screen. The phase difference between them is pi by 2 at P and pi at Q. The difference between the resultant intensity at P and Q is. So similar kind of problem we did. I1 given, I2 given. What is the resultant intensity formula? Yes, I1 is a I. So this is I2 which is equal to 9I. Now the resultant intensity formula which will be given as what? Tell me now. I1 plus I2 plus 2 root I1 I2 into cos theta. Now, so at point P, we have the angle. How much is angle now? 90 degrees now. Cos 90, 0. So this will come to be I1 plus I2 only now. So I plus, which is 9I. This is how much now? 10I. This is at the point P. Now at the point Q. So how much the phase difference they are given now? This is pi. Pi means what type of interference? Constructive or destructive? Destruct, destructive means minimum or maximum? Minimum. Yeah, so how much the minimum? Root I1 minus root I2 whole square. Now tell me now I1, I2 values we know. So that means at the point Q, which will be equal to how much now? This is root I minus root 9I ka whole square. So this is IQ is how much now? This is root I minus 3 root I na whole square. So that means intensity at Q, which is equal to minus 2 root I, this whole square will come to be a how much now? Which will be equal to 4 into I. So they are asking to find the difference only na. How much the difference now? So this is IP minus IQ. How much the difference is a p value 10, 4. That is what is 6I. So this is the option. Yes. Next one. Two light beams of intensities are ratio given 9:4 are allowed to interfere. The ratio of the intensity of maximum and intensity of minimum. Maximum to minimum ratio they ask me to find. Tell me now here. That means they asked him to find what tell me now I max by I min na. Yes, sir. So that is I max is how much? Root I1 plus root I2 whole square by I mean root I1 minus root I2 whole square. Yes. So we can substitute the values and simplify it now. Since it's directly ratio only now directly we can take it as I1 as a 9, I2 as a 4. So this is 9 plus that is root 4 whole square by that is root 9 minus root 4 the whole square. How much is value you can see now here? 3 plus 2 by 3 minus 2 na? Yes, sir. Whole square also? Yeah, whole square also. So this value how much now? 25. 25 by 1. Option B. Yes, sir. Next. The light waves from the two coherent sources have intensity given as like this. I1, I2 both are equal. In interference factor, the intensity of light at minimum is 0. What will be the intensity of light at maximum? How much the maximum intensity? They simply ask. So this is Simply put this thing here, that is root of I1 plus root I2 whole square. Yeah, tell me now here how much now? So this is root of I naught plus root of I naught whole square. How much is value? This is 2 root of I naught whole square, which will be equal to what you tell me now here, 4 I naught. Next. Now, see in this case what they are asking, the difference in the number of waves when yellow light propagate through air medium, air and vacuum of the same thickness is 1. The thickness of air is now, so they are saying here basically if they are asking the number of waves, means what, tell me now, which will be equal to, that is distance by lambda. Number of waves formula, distance or thickness by lambda. So this is, she is given as, refractive index is given, wavelength of yellow light is given. They are asking to find refractive index of air given. Wavelength of yellow light in vacuum is given. Okay. Okay. Now vacuum. So okay. So we'll consider this is okay. Now D, which will be equal to D by lambda, is given as what, tell me now, lambda naught by mu. Then mu is what, tell me now, this is mu D by lambda naught, where lambda naught is a wavelength in vacuum. Lambda naught is a wavelength in vacuum. Now, so they given this as, now tell me now basically the difference in the number of waves of yellow light propagate through air and vacuum given. So that is number of waves in air minus number of waves in vacuum they given, which is equal to 1 they given. So this will be equal to mu d by lambda naught. Thickness same they given. Same thickness. Okay. Now number of waves here. This is also what we can say now here. The mu means here this air. So air refractive index. And vacuum refractive index is 1. Refractive index of vacuum is how much now? 1 by this is lambda naught, which is equal to 1 they given. Now what they asking to find, you see this thing here. And what they asking to find now here, wavelength in vacuum is given now, so D value we should get. So tell me now what they given now, mu value given now, refractive index in air is this much. How much is value? 1.0003 into D by lambda naught. Wavelength is given as 6,000 angstroms. Angstrom means 10 power minus 10 by D value we don't know. This is also lambda naught 6,000 into 10 power minus 10. This value they given as 1. So we need to get the value of D value we need now. So you can see now if we have taken the D outside, then will come to be a either a denominator term also outside we have taken. So this is D by 6 into 10 power minus 7 into what, tell me now here, 1.00033 zeros minus 1, which is equal to 1. Now, so if you think now here D into this value, what will be now? 0.0003, which is equal to 6 into 10 power minus 7. So how much the D value, tell me now here? 6 into 10 power minus 7 by 3 into 10 power minus 4. That means what, tell me now? 2 into 10 power minus 3. They are asking the mm now. So how much the D value we can say now? This is 2 mm. Okay. Next one. Yeah, I think similar relation they given now. Now you try this. Hmm. Which option? Fourth option, correct. So, so this is directly we have seen now till now. So this is I max minus I min by I max plus I min, and which is equal to 2 root 2x by 2x plus 1 na? Fourth option. Take this thing. In the figure below, P and Q are two equally intense coherent sources emitting radiation of wavelength of 20 meters. The separation between P and Q is 5 meters. And the phase of P is ahead of Q by 90 degrees. Okay. A, B, C are the three distant points of observation, each equidistant from the midpoint of PQ. The intensity of radiation at PQP at ABC we need to find. Yeah, look at now here. They given the wavelength given, how much now wavelength lambda, which is given as a 20 meters. Okay, next. And they given that equidistance PQ and P having equal intensity, and the P phase is 90 degrees compared to Q. Okay, this point clear first of all. P intensity equal intensity, but the P having a P is ahead of Q by 90 degrees. Right, now we need to find at A, B, C, we have to find the intensity we need to find. Okay. Now, if we see here, first, now they given P to C distance given, not given. And PQ is given, a distance is given as a 5 meters. Okay, so if we observe carefully, first of all, at the point B, can you tell me now here this path difference now here? This thing P to B and Q to B is though the distances are same or different? How much distance now here P to B? And this is a midpoint which is O now here. They given this as, if I call this distance is now here X, this also X only now. O is a midpoint they are saying. And if we call, so this is Y. So for this thing, how much this PB distance you tell me now, square root of X square plus Y square. And DQ distance is how much now? That is square root of X square plus Y square. Is it fine? Now we need to find the path difference. Path difference means what? Tell me now. At the point B we are doing now first. At point B. At point B. So path difference means what? Tell me now. Delta X, which is given as what? Tell me now. PB minus QB. How much the path difference is a 0. Path difference is 0. But here, these two waves will have already, since because of the path difference is 0, now the phase difference caused because of the path difference, which will be equal to 0. Okay. And the net phase, if I say theta, which will be equal to what? Tell me now, delta phi plus initial phase difference between these two, how much now? 90 degrees now? That is 0 plus 90. Now phase difference between these two, how much now? This is 90 degrees. Between at the point B. 90 degrees means how much the intensity we need to see. So tell me now here, what is the resultant intensity at the point B we need to find? What is the resultant intensity formula? Yes, so this is I1 plus I2 plus 2 root of I1 I2 cos theta. So you can see now here the intensity at the point B we are doing now. I1 means I2 means I. Plus what tell me now here cos 90 value 0 only na. So how much this value will come now here, which is equal to 2i. Okay. So the intensity at the point B is 2i. Now let's find at the point A and C also. At the point A, yeah, look at now at the point A, we need to see the distances, we need to see now, path difference now. So we are talking at point A, we are talking now. Now, so the wave which is at P to A distance, how much you tell me now here? This is X, this is X. Let us call this distance is something X1 if I call. P to A, how much the P to A distance you tell me now? P to A distance and which is equal to 2X plus X1. Okay. Next, what is this thing Q to A distance now? Q to A distance is how much now? X1. So this means now we need the path difference we need now here. Path difference means delta X, which will be given as PA minus QA. How much will come now path difference now delta X? If subtract this thing will come it as 2X will come now. Yes. And what the X is a distance now. So this is look at now here. So X value P to Q. This is the X means 2X means P to Q distance only now. How much the P to Q distance they given now 5 meters given. So that means delta X which is equal to how much you tell me now 5 meters. Okay, now we need to find the path difference we have. Now we need the phase difference now here. The relation we have seen now here, delta phi by 2 pi, which is equal to what tell me now, delta x by lambda. Now from this we'll find the delta phi now. How much the delta phi now here? Delta phi by 2 pi and which is equal delta x is 5. Lambda wavelength is given how much now? 20 given. Wavelength given 20. So this value which is equal to 4 now. So that means delta phi which will be equal to pi by 2. Okay. Now we need theta value required. Theta value required which is equal to delta phi plus initial phase difference between P and Q is how much now? 90 degrees. So this is already we have 90. So finally theta value will becomes 90 plus 90. How much now? 180. Now at point A we have a phase difference is 180 degrees is there. Now at 180 degrees means what type of interference? Constructive or destructive? Yeah, destructive means intensity is a minimum or maximum. So that means intensity at point is how much now here? That is square root of I1 minus square root of I2 whole square now. Here I1, I2 both values are equal they are saying. That means how much the intensity at point A now? Which will become 0. Okay. Now we find at point A. Now we need to find at the point C. B also we got and now we'll get the at C we need to get. Now tell me now at the point C. At the point C. Yeah, you see this thing here. C we need to get now here. So that means P2A, if I call this distance is something x2. How much the P2C distance now? PC distance, which is x2. Next, Q2C. How much the Q2C distance? Yes, so this means Q2C and which is at 2x plus x2. Now the path difference means delta phi, which will be equal to what tell me now? Higher minus lower we say. QC minus PC. How much will come? This is 2x na? 2x means what tell me now from P to Q distance. PQ to distance 5 meters given. So that means delta phi value how much now? 5 meters. Delta phi is 5 meters. So that means what happens? You see this thing here. From that we'll get the sorry, this is delta x we got, not delta phi. Delta x we got. Here the path difference we got done. Now we need to get the phase difference we need to get. So phase difference means delta phi. So how much the delta phi now here? Delta phi. So this is delta pi by 2 pi, which is equal to what tell me now? Delta x by lambda. So that means delta phi by 2 pi. Delta x is pi by lambda value 20. So how much the delta phi will come to be a, which will come to be a pi by 2, which will come to be a pi by 2. Okay. So that means initially how much we have the phase difference now? Here, okay, here we need to get, so this is delta x we did now. So delta x will do here, this is PC minus QC now. PC minus QC, which will come minus 2x will come. That is, will come it as minus 5 meters. That's why here will come it as minus will come angle. Minus angle will come. Now, so finally this angle which will be equal to delta phi plus initial phase difference is pi by 2. So that's why theta will come to be a delta phi is pi by 2 plus again pi by 2 is added. So that's why theta value how much now? 0. If theta 0, what type of interference will happens now? Constructive or destructive? Then we have the intensity is maximum na. So that is square root of I1 plus square root of I2 whole square. Here I1, I2 both values are equal. That is root I plus root I whole square. How much this value tell me now? This is 2 root I. 2 root I whole square, which will be equal to what tell me now? 4I na. Now they ask him to find the ratios now here. I1 is to IA is 2, IB is 2, IC they ask him to find. So at A the intensity is 0. And at the point B how much we got? At the point B we have a 2, 2I. At the point B 2I. At the point C how much now? 4I. And if we see the ratios now, 0 is 2, we can 2 say cancel now here. 1 is to 2 now. So we have 0 is to 1 is to 2. Now see the option now. Option C. Like this, we need to solve these problems.